Imagine waking up one morning to a world transformed. A world where a fundamental force, ever present and invisible, has simply vanished. The sun is shining, birds are singing. But unbeknownst to you, a cosmic event has taken place. Gravity, the force that binds everything together, has suddenly stopped working. What would happen next? The answer is as fascinating as it is terrifying. And to truly grasp its impact, we first need to understand the mysterious force known as gravity and how intricately it weaves the fabric of our universe. Gravity is one of the four fundamental forces of nature, alongside electromagnetism and the strong and weak nuclear forces. It was first described by Sir Isaac Newton in the 17th century, who famously watched an apple fall from a tree and wondered why objects always fall straight down. Newton realized that every object in the universe attracts every other object, and the force of this attraction is what we call gravity. The strength of gravity depends on two things: the mass of the objects and the distance between them. The more massive an object, the stronger its gravitational pull. That's why the Earth, with its immense mass, pulls us toward it, keeping our feet firmly on the ground. Centuries later, Albert Einstein revolutionized our understanding of gravity with his theory of general relativity. According to Einstein, gravity isn't a force pulling objects together, but rather a warping of space and time itself. Picture a trampoline with a heavy ball in the center. The ball creates a dip, and if you roll smaller balls nearby, they spiral inward, following the curve of the fabric. That's how massive objects like stars and planets bend the fabric of space-time, causing other objects to move along curved paths. What we experience is the pull of gravity. Gravity does more than just keep us grounded. It governs the motion of the planets around the sun, holds galaxies together, and even determines the fate of the universe. Without gravity, the cosmos as we know it would be unrecognizable. But what would happen if, by some unfathomable twist of fate, gravity suddenly ceased to exist? Let's take this thought experiment step by step, exploring the consequences for us as individuals, for our planet, and for the entire universe. Let's begin at the most personal level, on Earth, in your own home. The moment gravity disappears, everything not physically attached to the ground would float free. Your morning cup of coffee, the chair you're sitting on, your own body. Suddenly, there would be nothing pulling you down. You'd begin to rise, as would your furniture, your pets, even the air you breathe. Without gravity, the atmosphere itself has no reason to cling to the planet. It would begin to drift away, dispersing into the vacuum of space. Breathing would quickly become impossible. But the chaos doesn't stop there. The oceans, held to Earth by gravity, would erupt into space, forming vast, shimmering clouds of water vapor. Rain, rivers, and lakes would all lose their anchor, with water droplets coalescing and floating off in every direction. Buildings, trees, and even the soil beneath your feet would lose cohesion as the pressure that gravity exerts on every layer of Earth's crust vanishes. The ground would begin to crumble, and the planet would start to shed its outer layers into the emptiness beyond. As you look out your window, you'd witness a surreal and terrifying spectacle. Cars, houses, trees, even entire cities lifting off the ground, rising ever higher as if some unseen hand were plucking them up. People and animals would find themselves helplessly adrift with nothing to hold them down. In seconds, the Earth would become a swirling mass of debris, with everything that once made up its surface dissolving into a chaotic, expanding cloud. But what about the planet itself? Gravity is the glue that holds Earth together. At its core, the immense pressure created by gravity keeps the planet's inner layers compressed, generating the heat and dynamics that power volcanoes, earthquakes, and even the magnetic field that protects us from solar radiation. Without gravity, the core would expand, the mantle would lose its structure, and the planet would begin to disintegrate from the inside out. Earth would no longer be a sphere, but a loose collection of rocks, metal, and dust, drifting apart in slow motion. Now, zooming out to a planetary scale, the consequences grow even more dire. Earth orbits the Sun thanks to the delicate balance between its forward velocity and the gravitational pull of the Sun. Remove gravity, and that balance is shattered. Our planet would no longer be bound to its orbit. and would instead shoot off in a straight line, travelling endlessly through space at its current speed, about 67,000 miles per hour. The Moon, which orbits Earth due to gravity, would do the same, breaking away instantly. All the other planets in our solar system would be similarly set adrift, their orbits disrupted. The beautiful dance of the planets would come to a sudden, chaotic end. The Sun itself, a massive ball of hydrogen and helium, is held together by the crushing force of its own gravity. The immense pressure at its core allows nuclear fusion to occur, generating the heat and light that sustains life on Earth. Without gravity, the Sun would rapidly expand, its hot gases dispersing into space. In mere moments, our solar system's central star would cease to exist, its material spreading out into the void. The ripple effects would extend far beyond our solar system. Throughout the galaxy, stars would lose the force that binds their atoms together, ending their nuclear lifespans. Planets, asteroids, and comets would scatter in all directions. The spiral arms of the Milky Way, held together by gravity, would unravel, with stars and interstellar gas drifting apart, never to reunite. Let's shift our gaze to the largest scale of all, the universe itself. Gravity is responsible for the formation of galaxies, stars, and planets. In the earliest moments after the Big Bang, it was gravity that caused tiny fluctuations in the density of matter to grow, eventually collapsing into stars and galaxies. Without it, the universe would be a thin, featureless soup of particles, never coalescing into the rich cosmic tapestry we see today. Even the fate of black holes, those mysterious regions where gravity is so intense that not even light can escape, would be transformed. With gravity gone, black holes would instantly evaporate, releasing their contents in a sudden burst of energy. The fabric of space-time itself, warped by the gravity of massive objects, would flatten out, erasing the cosmic web that connects galaxies across billions of light years. But what about us, mere humans, floating helplessly in the aftermath? Without gravity, our bodies would face immediate peril. Blood, no longer pulled downward, would pool in our heads, causing swelling, dizziness, and loss of consciousness. Our muscles and bones, designed to resist Earth's gravity, would rapidly weaken. Even the fluids in our cells would behave unpredictably, leading to potentially fatal imbalances. Daily life would become impossible. There would be no way to walk, stand, or even sit. Everyday tasks, eating, drinking, sleeping, would be fraught with difficulty. Our entire way of life, from the architecture of our cities to the way we move and interact, is shaped by gravity. In its absence, civilization as we know it would collapse in an instant. Of course, such a scenario is, in reality, impossible. Gravity is not a force that can simply be turned off like a light switch. It is woven into the very structure of the universe, described by the laws of physics that govern everything from the smallest subatomic particles to the largest galaxies. But imagining its sudden disappearance helps us appreciate just how vital and all-encompassing gravity truly is. It's easy to take gravity for granted because it is so constant, so reliable. Yet it is the reason why the Earth formed from a cloud of cosmic dust, why raindrops fall, why we can build skyscrapers and fly airplanes, why the Moon orbits the Earth and tides ebb and flow. It's the reason you can drop a ball and be certain it will hit the ground, and the reason you can look up at the night sky and see the graceful arcs of planets and stars. Think about the way gravity shapes our lives in subtle ways. It defines our sense of up and down, gives us weight, and subtly governs our movements. It inspires awe in the way it holds entire galaxies together and in the mind-bending extremes found near black holes. The story of gravity is the story of the universe itself, a force that brings order from chaos, structure from randomness, and stability from disorder. If you are floating above the Earth in this gravity-free scenario, you might catch a final glimpse of the world you once knew, a world where everything had its place, held together by the gentle, persistent pull of gravity. You'd see the oceans rising, the atmosphere escaping, the continents breaking apart, and then, gradually, the planet itself fading into a cloud of debris. Beyond, the sun would dissolve, the planets would vanish, and the stars themselves would fade away, leaving a silent, empty void. In this cosmic nightmare, the universe would unravel, and all the beauty and complexity that gravity made possible would be lost. The lesson is clear. Gravity is not just a force, but the architect of reality. Without it, there would be no planets, no stars, no galaxies, no life. But as you return from this thought experiment to the real world, where gravity is still very much at work, you can appreciate the extraordinary nature of the ordinary. Every step you take, every breath you draw, every glimpse of the sky above is a testament to the power of gravity. It is the silent, unseen force that holds the universe together, and whose absence would mean the end of everything we know. So the next time you drop your keys, or feel the gentle pull of the earth beneath your feet, remember, gravity may be invisible, but its influence is everywhere. It is the silent guardian of the cosmos, the thread that binds us all, and the reason that, against all odds, a universe of infinite possibility exists.